Okay, this video is to help with homework 3.0.1 and 3.0.2. This is talking about exponentials and logarithms. So I'm going to write it on a separate sheet of paper. I'm going to start right here with question number 1. So sometimes there's a situation like in question number 1 where everything's being raised to the third power. When you have that kind of situation, you can go ahead and reduce what's on the inside first. It'll just make your life a little bit easier rather than working with the bigger numbers. Feel free to work with the bigger numbers if you want to. I'm going to go ahead and reduce on the inside first. We're going to take a look at number 3 in just a minute, but I just wanted to point out the difference here is that this time the squared is only going to the things up here on the top row or in your numerator. So I'm going to have to work with that squared first, as opposed to, again, this one I can reduce inside my parentheses first. So let's go ahead and do that. So my exponent rules tell me that if I have something that has the same base, I can subtract my exponents. I'm going to go towards my bigger exponent. So in this case, I'm going to subtract my x's down. That's going to give me x to the 5 minus 4 power, or you can go ahead and just write that as a 1, but I wanted to kind of show you my work here. And then I'm going to subtract my y's towards my bigger power, which the 6 is bigger than the 2, so I'm going to say that's y to the 6 minus 2 power. All right, so up there on the top, that's going to be y to the 4th power. On the bottom, I'm going to have x to the 1st power, or just x, and then I'm going to raise all of that to the 3rd power. All right, because we are dividing, I can distribute that 3rd power into my parentheses. So I'm going to have y to the 4th to the 3rd power, and then on the bottom, I'm going to have x to the 1st to the 3rd power. And anytime I have an exponent that's being raised to an exponent, I'm going to multiply those exponents together. So my final answer will be y to the 12th over x to the 3rd power. And I'm going to leave those as y and x because they do not have the same base. If they had the same base, I'd want to subtract those exponents as well. Okay, like I said, on number 3, we're kind of in a unique situation because the 2 right here is only being applied to the numerator, and I know that because of those parentheses. So I'm going to start by distributing that 2 power, so that's going to be x cubed squared. I'm going to have y to the 0 power squared, and I'm going to have z really to the 1st power squared, just like that. And I can do that because these things are multiplied together. So if anything there was added or subtracted, I would not want to distribute my exponents, so be very careful with that. Okay, so when I have exponents raised to exponents, I'm going to multiply them together. That's going to give me x to the 6th power. I'm going to do 0 times 2 gives me 0, and 1 times 2 gives me 2. So that's going to leave me with all of this. I'm going to z down there on the bottom. I almost wrote a y, just like that. Okay, I do know that anything to the 0 power is 1, so really I'm just multiplying by a 1 right there. I don't really need to do anything with that. You could bring the 1 out to the front if you wanted to, but you really don't have to. And then again, I've got same bases, x and x. I'm going to subtract towards my bigger exponent. So I'm going to take those x's down to the bottom and say that that's x to the 7 minus 6 power. And then be careful right here when I deal with my z's, I'm going to go towards the 2 because if you think about a number line, 2 is bigger than negative 6. So with z, I'm going to have 2 minus negative 6 up there on the top. So again, subtract those exponents and subtract towards your bigger exponent. All right, so my minus and negative will become a plus up there on the top. That's going to give me z to the 8th power. And on the bottom, that would give me x to the 1st power, or just x. And that right there is a good way to leave that answer. All right, jumping down to number 5. Number 5 gets a little bit more involved here. You could go about this a lot of different ways. I'm going to go ahead and reduce on the inside of my fraction first. And so again, with my y's, I'm going to go towards the bigger exponent. So I'm going to subtract up and have y to the 7 minus 1 power. This is like having y to the 1st power right there. I've also got a z to the 1st power. And again, I'm going to bring my z's down because 1 on a number line is bigger then negative 4. So I'm going to have 1 minus negative 4 right there. And all of that is raised to the negative 2 power. I'm going to deal with that negative 2 here in just a second. All right, so let's keep that 4. That's going to give me y to the 6th power. And on the bottom, I'm going to change my minus and negative into a plus, and I'm going to have z to the 5th power. Okay, so I'm going to distribute my negative 2 into all of these things, but I know that a negative exponent, really what that does is that's going to make everything change sides of my fraction bar. So I'm going to go ahead and do that. Because I have a negative exponent, I'm going to flip what's on the numerator and what's in the denominator, and now say that all of that is just squared. So if you have something that's applying to that whole fraction that's a negative exponent like this, then you can flip your whole fraction upside down and then make that exponent a positive. And again, because now everything is multiplied together, I can distribute that square. That's going to be z to the 5th squared. And on the bottom, I'm going to have 4 squared and y to the 6th squared. So I can do that because everything's being multiplied together. Okay, so if they're on the top, 7 squared gives me 49. I'm going to multiply my exponents together. That's going to give me z to the 10th. So if I have an exponent being raised to an exponent, I'm going to multiply those together. And then 4 squared gives me 16. And 6 times 2 gives me y to the 12th. And again, I'm going to leave that just exactly the way it is because the z and the y have different bases. So we don't need to put those together. All right, the next one that I assigned was number 9. Number 9 hopefully was very easy for you, and that is 3 squared. So 3 squared gives me 9. This might be a good time to stop and make a list of just kind of some common exponents that you might need to know. Let's go 2 to the 4th is 16. Let's go 2 to the 5th is 32, and occasionally you'll see 2 to the 6th power. That's going to give me 64. So if you'll kind of commit these to memory, it sure will make problems like this a lot easier for you. Let's go 3 cubed is 27, and 3 to the 4th power is 81. That's about as big as we see on those. And then 4 squared is 16, and 4 cubed is 64. And then we might see 4 to the 4th power. Let's see here, I want to multiply that by 4. That gives me 4 times 4 is 16, carry my 1. So 256 right there. All right, and then maybe a couple of powers of 5. 5 squared gives me 25. 5 cubed is going to be 125. And 5 to the 4th power is 625. And then make sure that you know, 6 squared and 7 squared and all of those, but those should be kind of some of the bigger exponents that would help you with assignments like this. Okay, with the fraction exponents, we've talked a little bit about this in the review, but with the fraction exponents, the number that's on the bottom is your type of root. So in this case, I'm going to be taking the square root of 9, and then the number on the top, the numerator right there, that 3, is what we're going to raise it to the power of. I highly recommend taking the square root first, or the cube root first, so do your type of root first, because that'll give you a smaller number. In this case, the square root of 9 gives me 3. And then for my list right back up here, 3 cubed gives me 27. I forgot to box in my 9 up there. Okay, number 13 is similar to the one that we worked with the negative 2 power just a minute ago on number 5. I'm going to go ahead and take care of that negative first, and to do that, I'm going to flip my fraction upside down, and that'll change that negative 1/2 into a positive 1/2. So anytime you see a negative exponent, change sides of your fraction bar. All right, just like up above, the 1/2 power is going to be the square root. Because I'm dividing, I can distribute that to both the top and the bottom, and the square root of 16 gives me 4, and the square root of 9 gives me 3. Now, if I was doing that to solve some kind of equation, like if I had an equal sign, then I would need a plus or minus. But since we're just evaluating here, I can just use the positive version of that. All right, on 15, I have pi. You may remember that pi is 3.14. It doesn't really matter in this situation because we're raising it to the 0 power, and anything to the 0 power is 1. All right, on 19, let's go ahead and change sides of the fraction bar with that. So that's going to give me 1 over 81 to the 3/4 power. And then again, that number that's on the bottom of my fraction is going to be my type of root. So highly recommend doing the root first and then raising it to the power of the number that's up here in the numerator. So this one's your type of root, and then this is what the power is going to be. All right. Looking up above at my list that we made, I find out that 3 to the 4th power is 81. So the fourth root of 81 is going to be 3. And then 3 cubed is going to be 27. So again, keep that list up there kind of handy, and also commit to memory. All right, jumping to 21 now. 21 is like the ones that we did on that exponential and log review. So let me just kind of talk a little bit about this one. I'm trying to find out what it's equal to. So I'm going to use x to help me with that. You can use y, you can use any variable that you want to. It doesn't matter. But when I go to change a logarithm into an exponential form, which is what I want to do here, I'm going to start with my base, and your base is going to be the little number written right here. It's a big number on this one, but written kind of small. And then I'm going to bring it to the power of what's over here on this side, in this case x, and then I'm going to set it equal to the one that's back over there. So you may have heard a teacher talk maybe about a fish hook. Now there's a couple of things I could do to 36 to get to 6, like I could divide by 6, but what I notice on this one is that I'm working with an exponent. And since I have an exponent, what I'm going to need to do to 36 is take the square root of 36 to give me 6. And so we've talked a little bit about how when I take the square root, it's like raising something to the 1/2 power. So I'm going to say that the log base 36 of 6 is equal to 1/2. So 1/2 would give me that 36 to the 1/2 power would give me the square root of 36. Okay. Let me start on 25 by kind of rewriting this one. I'm going to rewrite that 0.25 as 1 over 4, just because in a minute you'll see I need the fraction version of that number. It'll really help me out. Again, I'm going to set that equal to x. You can set it equal to any variable that you want. And I'm going to start with my 4. I'm going to raise it to the power of x, and then I'm going to set it equal to this 1/4. Okay, so my 4's are the same, but I need something that will let that change sides of my fraction bar. So we've talked a little bit about how to change sides of the fraction bar. I'm going to need a negative exponent, and 4 to the 1st power would give me that 4 back. So what I find out here is that the log base 4 of 0.25, or 1/4, is equal to -1. All right, on 31, again, I'm going to use a variable to help me out. I'm going to start with my base of 16. I'm going to raise it to the x power, and I'm going to come back over here and find my 2 equal to 2. Okay, just like number 21, I need to take some kind of root of 16. So if you look up above and I find 16 in a couple of places, here and here, but I'm trying to get to where it's equal to 2. So I'm going to use this one over here so that I have that 2 to work with right there. So I know from my table up above that the 4th root of 16 is equal to 2. So the 4th root I could rewrite as 16 to the 1/4 power. And so I'm going to say that the log base 16 of 2 is equal to 1/4. You can't answer. Okay, and 37 gets a little bit hard. I'm going to still take my base, which is 9. I'm going to raise it to the power of x. Oops, that's too big. Raise it to the power of x, and I'm going to set it equal to the inside piece right there, which is 27. Now there's no power of 9 that would give me 27, but I do have a power of 3 that would give me 27. So what I'm going to do is I'm going to take the square root of 9, which would give me 3, and then I would take that 3 and I would cube it to give me 27. Okay, so the square root of 9 would give me 3, and then 3 cubed would give me 27. So let's rewrite that as a fractional exponent. That's going to give me 3/2. So 9 to the 3/2 power would equal 27. So it's kind of like what we were doing up there on number 11, but backwards. All right, so I'm going to say then that the log base 9 of 27 is equal to 3/2. All right, turning over to number 45. All right, 45, I've got kind of a lot of issues. This is our last one in this section. I'm going to set that equal to x. My base is 7. My exponent is x, and I'm going to make it equal to 1 over, and I'm going to go ahead and change this 7 into 7 to the 1/2 power. Again, I know that the square root is the same thing as the 1/2 power. Now, I kind of like to get these things on the same level, so a couple of different ways I could do this. I could think about that just being a negative, or I could actually go ahead and move that up. Remember that a negative exponent will change sides of the fraction bar, so I can move that up to the top up here by using a negative exponent. And now here's a little trick for you that we'll talk more about when we solve equations, but if your bases are equal, then your exponents have to be equal as well. So I'm going to say that the log base 7 of 1 over the square root of 7 is equal to negative 1/2. All right, on the next section, we're jumping to homework 3.0.2. So flip over to 3.0.2, and the first one we assigned was number 1. So on number 1, the directions tell us that we want to expand. And so in class, we talked a little bit about how when I expand, I'm going to go in a certain order. So I'm going to start with my exponents. Let me just write this down again for you. I'm going to start with my exponents. Then I'm going to take care of my multiplication. My multiplication will become addition. And then I'm going to take a look at my subtraction. My division. And my division will become subtraction. So division will become subtraction. And that's the order that I'm going to go in. I'm going to start with my exponent, I'm going to go to my multiply, and then I'm going to finish off with my division. All right, so on number 1, I don't have anything that's working with division. All right, let's take a look at, actually I'm going to go ahead and do my multiplication here first.